Thanks, everybody. Thanks for TT for hosting. And I also want to say special thanks to all the people who worked in the hackathon that I got to be a member of the jury. It was really inspiring work. Great event all around. And all three of us are excited. This is myself, Cobus, and Luc, all excited to talk to you a little bit about what we're calling distributed design intelligence, really about how we work as specialists within the context of a global architecture practice. Next slide, please. So what we want to do is talk a little bit about how we're thinking about sharing tools and developing tools now, but we wouldn't be able to do that without looking back a little bit on the history of KPF. This is an issue, if you go to the next slide, that we've been dealing with for a long time. So KPF has, I think, a 45-year history. Early explorations in kind of computational geometry go back to the 90s. We're showing here 2000s, I think, was the first time we had a kind of computational geometry group, and we continue to really push forward in ways, not only developing tools, but ways that these tools are distributed to architects in the firm. Next slide. So first, a little bit more about KPF and what we mean by specialist groups. Under the heading of advanced technologies, we have 6 specialized groups: infrastructure operations, digital practice, urban interface, environmental performance, urban interface, data science, and applied research. And if you go to the next slide, today you'll be hearing from 3 of us, 3 representatives of these specialist practices. Next slide. But the real challenge at KPF is not so much developing tools themselves, as we're finding out. It's really about the scale of the practice itself, and as I said before, the impact that we can have. So we have 7 offices around the world. We really are an integrated global practice. We have some upwards of 800 employees, maybe 500 architects. And if you go to the next slide, and then further complicating this is the idea of a studio-based culture. So not only do we have kind of a global practice with 7 different offices, but then within that we have these kind of amorphous constellations that you're seeing here, where architects move from project team to project team and from studio to studio. It just makes the challenge of developing workflows, efficient workflows, all the more challenging. And next slide. And then, of course, on top of that, we have our specialist groups that kind of float. And if of all our groups, these are probably the most connected and the ones that work between offices the most. Next slide. So traditionally, impact has been limited because there's been a very focused effort of our specialists to get intimately involved on projects, which we still do. We are a very practice and project focused firm. So the UI group may be working with 1 or 2 people on one project team, digital practice team another, and applied research another. And if we go to the next slide, what we really want to be doing is looking at how we can use centralized systems, not only to prevent siloing and kind of fractured workflows, but really to have a firm-wide impact to make sure that individual users, architects, designers have all of the advantages of working in a large global firm, while at the same time being able to have the advantages of working in their small studio-based culture. And with that, I'll pass it on. Oh, and so talking about how we've done this in the past, obviously the low-hanging fruit is to take a look at the tools themselves and think about how we can standardize this. This is something that's been an ongoing effort. I'm sure it has been in all of the firms of people present here, looking at ways we can standardize geometry inputs and outputs so that there is kind of a culture of script sharing in the firm. So we've been doing that for quite a while. Next slide. And then taking that one step further, another path towards broadening our impact is through things like online repositories of scripts. What you see here is our data advanced modeling site on our internal intranet. Here you can get a lot of information about different analysis tools. And we like this because it's a bit of a gradient from kind of self-service scripts that people can download and use immediately to other ones that are a bit more complex with contact information of the specialist who can help your team out. Next slide. But even with these, we've seen kind of a limited impact, mainly because of sometimes a reticence, which I'm sure all of you have seen, about getting into changing workflows, getting into different software packages. Using Grasshopper, it can be a challenge. If we go to the next slide. So what we've seen is this was the first attempt by the UI group to kind of develop a plugin within Rhino itself. I mean, we've been doing this for a while, but here a more consolidated effort about putting, you know, a more Rhino-like front-end interface onto our essentially back-end Grasshopper scripts. We were really surprised by the uptick in usage from this. Finding out that the friction was very much had to do with really changing the workflow. We understand designers these days are being presented with ever more compact schedules, more complexity in the projects themselves. So we're starting to understand that actually just the need to switch from one platform to the other is a significant hurdle to increasing the use of these analysis tools. Next slide. And so this slide shows kind of an evolution of taking that same idea, but actually, you know, focusing on the user interface. So whereas what we showed in the Rhino example was some basic Windows forms, here we really worked and worked on the user interface as a design problem in its own right, which, you know, rightly it should be considered. And many iterations about inputs and outputs and simplifying interface. And if you go to the next slide, to the point here where you're seeing Scout, I think this is one of the latest iterations, very simplified user interface that allows you to digest fairly complex design data in real time and weigh options in a way that design teams can actually act upon and communicate to their clients. And this is our goal. The image is a bit cartoonish, but I think we all understand the point. The AEC industry is kind of known for the variety of tools we use. And we see this as an advantage. We see ourselves as a culture that's open to using new tools as they come on board. But at the same time, there can be a bit of an analysis paralysis on the design side if there are too many tools presented. So what we would really love to do and what we aspire to is keep the focus on design and the actual problems at hand and allow as much of the complexity to be hidden behind the scenes in kind of a back end of the interface.
Thanks, Nick. And thank you, everybody. So I'll take it from here a little bit. And what I want to do is just lift it at a little bit of a more larger scale view of distributed process or distributed intelligence as such. I think to note here as well that the advanced technology efforts work quite seamlessly together to help deliver to the designers themselves. And the focus of the designers is to design and not to be software engineers or specialists as such. And if we look at different industries at the moment related to medical or legal or so forth, we see more and more of these kind of augmentation of the machine and the human happening. So release the designers to do the stuff that they need to do as humans and can deliver better projects, while the backend or the server side as such will do the compute for them. Of course, there's designers that want to get involved in the heavy compute, but for most cases, they just want to have this kind of one-click solution. Next slide, please. So if we look at the traditional kind of way, and I'll just sketch us out a little bit here, where we have designers with a client application, be that a Rhino or a Revit or a 3ds Max, V-Ray, Inkscape, and so forth, access within KPF the files through file servers, be that in the cloud or on-prem. This is very much a traditional way of doing it. Next slide, please. But now with new technologies like Rhino Compute and others, we are starting to introduce a secondary layer of server-side compute. where users will actually access through a client application, a Rhino compute, or a visual compute, or a machine learning compute function. And these can be distributed across the world. They can be cached or localized as such as needed. And this make quite a sort of harmonious approach to design, taking the compute or the heavy requirement for hardware and knowledge on the software side away from designers to the cloud side. Next, please. And as Nick mentioned earlier, what we want the designers to have is a simple, intuitive interface. I'm not going to mention names here, but there's a visual application that happened to have done it very accurately. And it's basically democratized compute technology to 90% of our designers instead of a small group of 10 or 20%. What happens on the left-hand side is what the designer sees and the input that the designer is given through a UX design. And at the back end, we do all the compute and the distribution of the compute through the multiple servers. Next slide, please. And if you look at a longer term and a bigger sort of picture of how we're looking at this, is that you'll have this kind of experience layer where the designers are interfacing with technology, and you have the application layer that's sitting on the compute servers, distributed. And the application layer is very much made up from small multiple tasks, be that run a compute or machine learning or normal Python scripts or whatever the case might be, where the designer can pull those functions through an interface and perform the compute task that they want to do, evaluate that task, and then go back to the compute, to the design process again, and cycle that through until they want to go to the next stage and next stage of the actual design. Next, please. And if you look at the total aspect of this, when we look at compute for geometry, visualization, analysis, spatial, social data, and eventually simulating all these functions together to give the designers a design experience interface instead of a hardcore application interface. This is the kind of longer term goal that we want to go to. And the end result of that will be is make a change in your geometry and actually experience that through a full immersive environment. Next, please. This is one of the ways we're doing this. This is a real-time stream with about 45 files live linked, including Rhino and Grasshopper, where the user can actually adjust parameters and see these update in real time. Next slide, please. Here we have a CFD case as such, and we do this with analysis data as well, where we have a engineering compute CFD as well as a machine learning compute CFD overlaid on top of each other. And I just want to dig into this quickly before Luc shows more of the specific Rhino compute functions. Next slide, please. And just to explain how this actually works, the user sits on the left-hand side with Rhino and adjusts the massing models. That is fed through Grasshopper automatically to a Rhino compute server that will pre-process it, send it across to a data science workstation, and feed that to a real-time visualization engine that is then fed through a browser back to the client. In this case, the client may not have the capability to render at high res. Next, please. So how that works is the client application sits in the middle. That's where the user experience is happening, and this is the proof of concept that we've managed to build. The user will access the files from the cloud. Next slide, please. From there, they will do their design iterations and functions and so forth, and there'll be a bounce between two different servers, the Rhino compute server as well as the data science workstation. Just so you know, the Rhino compute server is sitting in a data center outside London. The data science workstation is sitting in New York. And in this case, the client was actually in London as well. Next slide, please. The result of that is then fed through Grasshopper to a data aggregator, which is sitting outside London as well, and then to a ray trace server engine that then actually pixel streams, next slide please, the result of the geometry changes in a visual manner. We are currently working on pixel streaming that to lighter devices such as headsets and tablets as well. So the designers do not need both the capabilities of high-end knowledge of the software, and also they don't need the high-end compute power in front of them. Next slide, please.
Thanks, Cobus. I'm going to wrap up by going through a few case studies, which sort of position different approaches to developing distributing tools within the broader platform that Cobus just outlined, to make them a little bit more specific and tangible, and maybe how you might also approach something similar in your practice. And so for kind of the tool creation, that always starts in Grasshopper and could either be specialists like us or designers within the firm who do know Grasshopper. In this case, we're using Grasshopper to build tools to build project-specific to solve project-specific problems, and really seeing in a stack like this is as a fantastic prototyping tool. And then if the tool seems to have promise beyond a specific project, we look at kind of first the right side, what's the user interface and how do we deliver it back to our audience in the most productive way possible, and then back out, and maybe user interface relative to time to production, back out the best programming method and move that to a backend. And so depending on kind of the need of the user and how you're fitting within a workflow, it could be anywhere from hours to days to weeks, or even kind of months, depending on the scale of what you're doing. And while we're connecting these to some specific user interfaces, back to Grasshopper, images and PDF, Rhino geometry, front-end visualization like Omniverse, Rhino plugins, or the web, kind of the idea is once you have this platform, this backend platform, you can connect them to whatever the appropriate user interface is. So I'll go through some of these and talk about the thinking around them. So this first one is using Hops, which is a new Grasshopper component that allows you to link to another Grasshopper file that can sit anywhere, really anything running a function anywhere. It spins up a local instance of Rhino Compute to handle the processing. And so in this case, we're running a daylight simulation, which is heavy computationally. So we're using hops for three things, which also apply to compute. But the time difference, you can see this is sort of hours to set up and get running versus days or weeks for the other ones, to help you identify where you might use these within your workflow. So in this case, we can put it on a server that's faster than in the typical designers have, so it speeds it up. It also handles dealing with Grasshopper plugins. We may be developing stuff with plugins that the design studio isn't using yet, so there's a whole host of headaches that avoids. And then finally, versioning. There's only one file we have to replace. We don't have to track down in multiple locations, so it becomes really useful in this case and is quick to deploy. Next, moving to some compute examples. This is using Rhino Compute to take a Grasshopper definition that our environmental performance team uses to run out climate analysis. But in this case, we're using it to run out climate analysis for all 2,500 cities that have weather files, and producing the analysis that normally takes them an hour or two to do. And they do this for every single project. And so in this case, the stack is pretty simple. We're using Python and a Jupyter notebook to run the Grasshopper definition that they have on a compute server. Compute is really great because you can leverage all of the assets you already have, all of the Grasshopper tools you've already built out in terms of functionality. And so that's getting the results of the climate analysis, bringing that back to Jupyter, and then outputting into the graphic format to compile into a PDF, which then the environmental performance team can use. So, this is a couple days of work. The majority is actually just running out the 2,500 files. And then finally, going back to what Nick talked about, what sort of kicked this off was an effort to get our core analysis and simulation tools up onto compute behind a Rhino plugin wrapper, trying to get these accessible to anyone in the office. And then the way this stack works here is we have this kind of backend handling everything the user doesn't need to deal with, but two kind of end user interfaces. The first one is a local Rhino where anyone designing can be modeling, getting analysis results, and can be multiple designers on the same project. Then they can send the models and analysis they like up to AWS, which populates our 3D web viewer Scout, which is the other end user interface where the senior designer can just refresh the browser, see new designs come in, we can present to clients. And really with this backend, we can connect to whatever interfaces we want. And one thing I want to highlight here that's also a danger with making tools really easy and accessible is there's the challenge that people won't actually think about the application if it's too easy. So one of the things that we've done is we've actually switched the project setup for these analysis tools away from the Rhino panel in a Rhino plugin and into a web interface, so that an expert from the specialty groups, either the UI team or the EP team, works with a team to make sure they're using the right tools, options are set, and actually how to interpret the results correctly. And the great part about having a platform like this is this switch was super easy. We didn't have to change anything. It's just the kind of the UX and the UI, and then otherwise the tool works exactly the same. And so to sum up, which we've been sort of hammering home, is we really want to meet users where they are, and that's where the specialists were creating this back end and then just creating the right user interface, so it's kind of as easy as possible for the designers to interact with these tools and the environments they're used to. Thanks.